Good morning, my YouTube viewers. Crystal here. What I wanted to do this morning was I wanted to give you the solution to the Analytics VidHaya joke prediction competition question. I worked on it a while and I submitted it onto the Analytics VidHaya solution checker, and my highest score that I got was 4.9, and the winning score was 3.9. So I was only really 1 point below the winning score. And because it was such a big file, I just decided I'm not going to try to work on it anymore, because it took me a really long time to run the program, because the program had like over a million rows, and then so it had to take time to process through all those a million rows. And so every time I tried to make a modification to the program or something like that, it would just sometimes it would crash on me, but if it went all the way through, then it would just it would just take such a long time. It would take a minimum of an hour. So I decided I'm going to leave the joke prediction as it is, since I got a 4.9 and the lowest was 3.9. And I thought, well, that's pretty good. There were people that their scores were a lot worse than mine, so I'll go ahead and accept that score, just because of the complexity of the problem and the simple fact that I had like close to a million rows of data it had to go through, and it took such a long time to go through it. And this is another reason why I need to get a more powerful computer, which I'm going to be looking to get next year after my birthday. And so the first thing I'm going to do is I'm going to read you your problem statement for this Analytics VidHaya joke prediction competition question. And the problem statement is the data set contains anonymous ratings, neg 10 to 10, provided by a total of 41,000 users. Train file contains 1.1 million ratings, and in the test file, the user needs to predict the ratings provided by the same set of users on a different set of jokes. The complete text for all 139 jokes is also provided in a separate CSV file. Given the combination of user and joke, the task is to predict the rating given by that user to the joke in the test set. So the first thing I did was I imported my libraries. So you can see here the libraries that I imported, but I didn't use all of those libraries, which I don't think that I used Binarizer, because what I had done was I had looked at another solution, and the other solution used Binarizer, but I don't think I used that. So I didn't use all of the libraries that it says here, but I'm not going to touch it because it takes such a long time to run the program. I'm just going to leave it the way it is. And then I loaded the files. You can see we had 4 files. We had a joke train, jokes, joke test, and joke sample. The files were so big that I was not able to put them on GitHub. So what I had to do was I had to load them up onto my little Chromebook. And so that's what you're seeing, that I had to load them onto my Chromebook, and I'm calling it up from the Chromebook. So we looked at the train file. You see we had an ID, a user ID, a joke ID, and a rating. We looked at the jokes. You had a joke ID and the joke text. We looked at the test file. You had an ID, a user ID, and a joke ID. And we look at the sample sub, which is what Analytics VidHaya wants to see when we submit our work. We have an ID and a rating. So the first thing I had to do was I had to merge the data sets. So data train equals train.merge jokes on joke ID and to the left. And then you can see data train right here. And then I had to merge the data test set in the same way that I merged the data train set. So that's exactly the same, except for the data test set does not have a joke rating. had to check for any null values. Fortunately, there were not any null values, so that's not something I had to worry about. Here's a heat map of the joke ratings if you'd like to see it. Then I had to pre-process the data so you can see all the ratings from a -10 to a +10, and most of the ratings were from 0 to 5, except for there were a lot of 10s as well. Then what we did was we did a group by on the rating, so you can see all the different rating values. There were 641 rating values, and you can see how many counts they got of that. So we did a heat map on the rating, and so again you can see most of the ratings were between 0 and 5, and some of them at 10. So what we did here was we imported our natural language processing libraries, and we removed the stop words from the text. And this took a long time to do it. It took a long time to do that because I had over 1.1 million jokes to go through, or 1.1 million rows to go through. So it took a really long time to go through this to remove all the stop words. And the next thing we did was we removed the lowercase, where we made everything lowercase is what we did. And what I could have done is there was an extra line of code to remove all the special characters, but there was something wrong with this program, and I'll show you what is wrong with the program, and I think that is probably affecting the score. Is that whenever you replace a special character with a space, then what happens is, if you see over here, you see the word trouble. Well, instead of TROUBLE, they've got TROUBL, and I'm not sure exactly how that works. It seems to me that they took out the E's. The E's have been taken out, or the last letter of the word has been taken out. I probably have to investigate that and try to find out what is the problem. But that was a consequence of taking out all of these special characters, which I didn't take out the special characters in the end. But that's a consequence of, I don't know, of making the text lowercase. But that was just one thing. What orange sounds like parrot, carrot, and they said, what is orange and sounds like a parrot? And so for some reason, this program, it's taking out the last letter. I'm not sure why it does that, but it does that. And I do think that is affecting the rating. So that's something I'll have to investigate, perhaps on a data set that's not got a million rows of data. And the next thing we did was we just wanted to see the joke words. So you can see the joke words here. There's just to give you an idea of the words. And you can see here, like course, the E's been taken out. So I'm not sure why the E has been taken out. That's something I will have to investigate. And then we defined our X, Y, and X test values. So your Y is your train rating, X is data train process text, and X test is data test process text. So the next thing we do is we break our data set down into training and test sets. I gave it a test size of 0.1 and a random state of 42. We wanted to see the shape of X train, X val, Y train, Y val. So it's always a good idea to look at the shape. And then the next thing we did was we converted the words to frequency vectors, and you can see how the words were converted to frequency vectors. So we had to assign a value for train TF-IDF was derived from X-train. Val TF-IDF was derived from X-val, and X-test TF-IDF was derived from X-test. We wanted to see the shape of train TF-IDF, val TF-IDF, and X-test TF-IDF, and you can see that there are a lot more rows and columns than there had been before it had been vectorized. You have the same amount of rows, but you have more columns. So we selected our model. The model that I selected that I was able to get this system to work on was SGD regressor, and that's something to do with stochastic gradient descent, something like that. And I tried to use other models, and this was the only one that I could get to work on this. So then what we did was we predicted on val TF-IDF, and we predicted on the Y train TF-IDF, and so you can see the scores here. And then what we did was we did a comparison of the actual joke rating versus the predicted joke rating, which doesn't look that hot to me. And then what we did was we predicted on X-test TF-IDF, and we gave that final labels, and the final result is the data frame that we created, and the test ID and final labels goes into the result. We created a CSV file out of that, and we got a little message saying your submission was successfully saved, and we upload the submission. And then what you would do is you would come over here, and it's not connected, and I'm not going to try to connect it because of the really long amount of time it takes to actually run this program. But what you would have is you would see this file that says submission. You would see the file that says submission.csv. And then what would happen is you would click onto the three dots to download it. And then when you downloaded it, you could load it up into the Analytics VidHaya website to get your score, which is what I did. And I'll just look, I know you can't see it, but I'll just look on my submissions, and I just continuously got a 4.9 no matter what I did. And but the leaderboard, the best score was 3.9. So it was only one point, like one number below the best score. And the worst score, I'll tell you, the worst score was 2505. So I didn't really do that badly. So I decided, I'll just leave this like it is. I'm not going to I'm not going to do any more work on it, because it does take a million rows of data. It does take a really long time to go through it on my little Chromebook. So that concludes this solution. I put the solution on my Google Colab, and the reason why is because the files were so large I could not put them on GitHub, and I don't really tend